Okay, welcome back to Shabab. Today we will have a short quiz. Short quiz mean the quiz will be as follows. One question and you need to answer numerically. One little square field. You don't need to scan your solution, and the solution will be accepted within a range of 15% up down, either plus or minus. So you should not worry about your calculator taking the first or second digit, okay? There's no big deal about that. And it's going to be 12 minutes only. It's a little tiny question, not more. I hope you will like it. The grades for homework number 2 are already on. And I honestly spend like, I don't know how many hours grading it. I regretted it, honestly. I was supposed to stop not grading it and cancel the quiz, because it's not only that many of you wrote comment in the, not many, but some of you wrote comment and what is this? We're not ready for this. I don't know what were you ready for, but I am gonna cancel that quiz, just to let you know. I marked it. I told you that it isn't easy for me to mark it with my pen. So if you have any question, why did you get that mark? Please let me know. I promise that not this quiz will grade itself, but the next quiz, if you need to mark the, if you need to submit hard copies, soft copies scanned, I promise that I will do the quiz in a way that enables me to mark it with my hand, so you can get a better feedback. But for now, the feedback can only be obtained by email maybe, or if you are, if you can allocate 10 minutes, you can always talk to me. Now, today, we will leave the quiz to the end. I honestly was thinking that I wanted you to have the quiz in the beginning. My only fear is that some of you might assume that the quiz will be open for student at the end, and this may not be good for you. I know you make assumption, you don't want anybody to violate them. And the reason why I wanted you to pay attention, because this part now of this chapter 6 is going to go in the exam. So please pay attention. I know how much you would probably now hide and try to, read about the quiz, but I hope you are prepared well so you can pay attention to the lecture. Today we are going to talk about fatigue failure. And fatigue usually is a result of the application of cyclic loading. And what are we gonna do? You probably know a little bit about fatigue from material science, but what are we gonna cover? This chapter is a lengthy one, chapter 6. The good part is that by finishing today and maybe Sunday class, we will be almost in schedule, which is very nice. So finally, I was avoiding the fact that we may need to have a night session to catch with the material. I may, Ya Shabab, announce next week before the exam to have a help session for you. So I will announce that. I know it may not be good for you in terms of the time, you may not like it, but I have to set one time, I don't know, 1.5 hours or something. I will solve a few problems and that's it. So this is gonna be announced next week, inshallah. Early next week, maybe during the weekend. So we'll talk about introduction about fatigue. Then we'll talk about approaches to fatigue. Then we'll talk about the fatigue life methods, stress life, endurance limit, fatigue strength, endurance limit, modifying factors, a very long list, but hopefully it will be clear more when we, inshallah, move further. يا شباب, the fluctuation of stresses, the variation of stresses, of loads with respect to time, we always tend to make it easy for us and represented by a sinusoidal wave, meaning that the force is changing with respect to time. But in reality, it may hardly follow a sinusoidal wave. What we understand is that today, ya shabab, with the Arduino age, you can easily connect a sensor to your computer, and if that sensor is able to detect the magnitude of, let's say, the displacement or something, and you stick it to your car, a suspension arm or any other place, and then you drive your car, you will just get something like this. And what is this doing, ya shabab? Very simple. If we take the علاق الملابس يا شباب, string for the cloth, which is famously metal here in Saudi Arabia, and you come and you cut it from this piece to this, and then you end up having this nice straight piece. You go give it to anybody, even a kid, a child, and tell him, break it. The word break it indicates that you want to have this broken into two pieces. That's what break it means. So people will try to build. They will see that, oh my God, I can't do anything to this. And then probably the tendency, this is something we, as a human, I mean, probably we develop with it, is that we will tend to move around until we determine that, there is a weak point in the lateral direction. But when you bend it, it doesn't break into two halves. So naturally, you will try to bend it back and forth, back and forth. By the way, if you do this at home, if you never did it, you have to be very careful, because back and forth will make the middle joint, which is now being bent back and forth, very, very, very hard, especially if you continue doing this a lot. Now, at a point of time, it will break. The failure, because you were bending it up, down, is called fatigue failure. The word fatigue came from to distinguish other failure. Is there any other type of failures? Of course. You can take the same string and hang it on a machine, and then tell the machine, move apart 100 meters per second. And then in a flash, you will hear a sound, tap, and then it's broken. That's called impact. It's a dynamic load. It's too fast, too fast. And of course, there is the quasi-static or the static loading, which we take the string and then we apply load gradually until it breaks. That's a static loading. There is a creep failure, and so on. So sometimes we call this variable, repeated, alternating, fluctuating stresses, and there are actually some meanings behind those names, repeated loading or variable or alternating. We'll talk about them later. But just to give you an example, the speedometer ya shabab, in your car, you have one which measures the speed and the other one which measures the RPM. The one which measures the RPM is the interesting one. The one which measures the speed is the boring one. It's very boring, 100, 200, whatever. But this one is measured in RPM. And if you keep your eyes on it and think about it for 1 single second, when you are at 4 or 5, it means that the crankshaft in the car, where, you know, this reciprocating motion of the pistons inside the engine chamber, which blow and move up and down and then do all the motion, are doing this 4,000 times per minute. That's 4,000. 7 means 7,000, which means that this guy is rotating several thousand in a minute. And you go to your, I don't know, friend or something. There are people who has cars which have, you know, which they bought them like 20 years ago. And you ask them, did this fail? Did this crank fail? Because by now they probably burned several, maybe 100 millions of cycles. Is that possible? بينما يا شباب العلاق هذا، علاق الملابس، maybe 70, 60 cycles and it's over. And why they don't heat up? Why العلاق حق الملابس ترى، be careful, it can burn you, and it will burn you really, really hard, because its temperature reaches to very, very, very high range. So we will talk about all of these later. These are just a question to stimulate your thinking. Now, so machines, we are mechanical engineers. Now, maybe when we did CE203, ya shabab, and when we did all of what we did before in chapter 3, 4, and 5, looks like we are dealing with a static failure, okay? But we are mechanical engineers. We make machines. I mean, most of our machines move. Once they move, there is cycling. Do you know, shabab, the fact that you eat, you induce cyclic loading on your teeth. The fact that you walk, there is, I think, a human being can, you know, have around several, maybe 2-something millions cycle a year. I don't remember their numbers. I can bring them up for you. Cyclic loading is everywhere. Because your heart is beating, there is cyclic loading. Everywhere there is cyclic loading. So fatigue is very important, especially for us. So, so what happened? The problem is this, Isha. I want you to look down in your screen and look at this one. This is the problem. The problem إنه الفatigue gives you no warning. هو السبب اللي يعني, let's make a story. Let's make an interesting, funny story. Let's assume you are now in your high school and your father decided to teach you how to drive. And let's assume that your father has his loved car who he bought, maybe 15 years ago. He liked it, and he's going to teach you how to drive with that car. And then you drive the car, and after maybe several months, now you get your license, you can drive, and then something breaks, like the crankshaft or some other connecting rod or something like that. And then your father would say, how bad of a driver you are. I've been driving this car for 15 years and nothing happened to it. And then you show up and then that rod just failed, just like that. You're a bad driver. But unfortunately for Daddy, he was the one who was doing everything. What happened? What's the story? Fatigue starts very early on, very, very early on, in the, you know, range of less than a size, which is less than a grain size, way less than a grain size. So if we think about a connecting rod like this, or then this is not actually a connecting rod. I was planning to plot something else let me show you. The connecting rod usually is something, has a circle, and then it has a wheel like that, whatever. So what happened is that usually there, a point, a very little tiny point. This tiny point could be due to micro defect or a little tiny, you know, porosity. And then what happened around the porosity? The stress will be high, and maybe the stress at this point will reach above yielding or yielding even, although the stress at all other points is elastic. But that point, because the stress concentration, it might be micro or even nanoplasticity. That little thing will start to growing a crack that nobody can see. Maybe you need a scanning electron microscope to see it. But over the 15 years, your daddy was just growing that crack just like a baby. He's like, every day he's feeding this crack, cycles after cycles after cycles. And the interesting thing about fatigue, شباب, إنه الكراك هذا will just grow like this. Just like that. No ductile behavior, nothing, no signs, no nicking, nothing, no chips, nothing. I mean, if you look at the rod, you may not even be able to see the crack. Maybe if you are very strong and you bend it, you can see it opening up. But because the entire material is elastic, it will close it. So then what happened? You came along, there was only a little tiny bit, and you finished it. Yeah, because you are rough. No, probably, yeah. But your roughness just killed the last 1 year or something. You accelerated it. Maybe your father would have 1 extra year, وانت جيت وقعدت تفحط وخليته شهر بس. Maybe. But he was doing the entire work. He spent 15 years, millions of cycles growing that crack. طبعا, this is not to say that your father is guilty. What I'm saying is that the machine has defects always. And this is why the crack was gonna grow no matter what. This is why some cars ultimately fail. Some others are not. Maybe they are really designed well to survive a trillion, a billion cycle, I don't know. And this is way beyond the lifetime of a human being. That's the reason. So it's sudden and total, and it's very dangerous. It fails just like that. And it is very complex. Why? Because it's like, I mean, it fails. The material is ductile, it's a steel, but it feels like a brittle. Very strange. You see a crack growing. Let me show you. I think I have some pictures. Let me jump and try to show them to you. No, I don't. Oh, that's very strange. Maybe I will show them to you later. But what happened? The fact that a ductile material fell like a brittle material. It's just very strange. So what happened? Usually, fatigue has multiple stages. The first one, we call it the micro crack stage, where the cracks start in, as I said, very little tiny dislocation or microvoid, discontinuity. And then this become this micro crack grow into a macro crack. Now, but then the last stage, which is the final one, this is where maybe fatigue eaten up 70% of the cross section. خلاص, cross section راح خلص ما بقى في شيء. يعني if you think about a cross section like this with a crack, this is the only remaining part in the cross section. خلاص, هذا ممكن one single load, لأنه الاريا هنا صارت صغيرة. أنت ما عاد تقسم الفورس over this area. No, you divide it over this area. So one single force while you are cycling up, down, and it breaks it. Okay, this is an example, very interesting one. Remember this image very well. Because يا شباب fatigue grow in a cyclic fashion, and in many ways this cycling goes to tension and a little bit of compression, or even tension and too much compression, or even tension and tension. What happened? The fact that when the material breaks, the surface of it, you are cracking it, become rough. But when you close the crack, these asperities, we call them, these little rough guys, they smash into each other, and then they become smooth. And then you grow the crack further. So the crack becomes smooth, and then you grow here, and then you cycle, and it becomes smooth, and then you grow. In the end of the day, if you notice, this area, ya akhwan, is very smooth. Look at it. Here, it's very, very smooth. And this part is also smooth, while this one is rough. شو اللي صاير؟ هذا الكراك started from here and started from here. Two region. وبدأ يكبر. Apparently, from my understanding, of course, is that the crack started at this side earlier. قبل يعني مثلا بعد سنة. بينما هذا بدأ مثلا بعد 4 سنوات. فهذا خلال ال4 سنوات كبر إلين ما وصل إلى هنا. مثلا بعد 4 سنوات a new crack started and started to grow right here. So both of them joined forces, but one of them made bigger area than the other. فخلاص الماتيريال مسكينة ما بقى فيها إلا هذا. الكروس سكشن ما بقى فيه إلا القطعة الصغيرة هذه. One day it fractured. This fracture, because there is no cycling يا أخوان, there is no smashing of asperities, it become rough. عشان كذا when you examine fatigue or when you examine a failed component, just look at it with your eyes, and you may notice that there is a shiny region and there is a dim region. Automatically, without a microscope, maybe with a magnifying lens, you will know that the shiny region belongs to fatigue. And by looking at the area, يعني على سبيل المثال نفترض انه لا قدر الله هذا الجزء من طيارة. شوفوا الآن نعلمكم شلون تصيرون investigator, ها? You become a forensic investigator. This is an aeroplane. نفترض انها هي حق الخطوط AMM airline. Just I fake it. Okay. هذه الخطوط من المفترض ان هي كل 5000 hour, كل 10,000 hour, or every 100 flight or something, they need to inspect certain part in the airplane. Now, they should, when they inspect, they use X-ray and other technologies, they should come and scan this part. And logically, when they see a little tiny crack, okay, they will know if it is too much or too little. And then what happened, they will decide to replace the part. But let's assume إنه الطيارة طاحت وللأسف ماتت الناس وجاو قال لهم ما تلمسون شيء، الحين بيجون المحققين. جاوا المحققين ومعاهم أنت mechanical engineer. You came to this part because you know from the airline manufacturer that this part is critical, it grow cracks. So دورته وحصلته، جيبه وديه اللاب نظفه and scan it. And suddenly you see this. إيش معنى الكلام؟ معنى الكلام إن الخطأ راكب راس AMM إلى هنا من تحت إلى فوق، وهم الغلطانين ولازم يعوضون كل الناس اللي ماتت. ليه؟ They were missing inspection. Somebody is responsible. بنقول لهم بالإثبات يا جماعة الكراك قاعد يكبر 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 وأنتم مفروض تسوون سكان. معقولة شفتوه كبر إلى هالحد قبل الرحلة اللي قبل ولا اللي قبل؟ هذا يحتاج له سنوات. معقولة ما سويتوا inspection وانكسر وهو اللي طيح الطيارة. This is it. This is how important fatigue is. If we look under the microscope, we will see what I told you. We will see what is known as fatigue striations. Those are the lines. You see, each line represents a growth of the crack by one little increment. We can even calculate the number of cycles from this. Okay? There are methods to know from this how many cycles the crack was growing. By the way, this is one single grain. يا شباب, one single grain, this one. والكراك قاعد يمشي فيها. 1, 2, 3, 4. How many? Per day, per year. And this one is a fractured part. This is the other, I think, adjacent grain, which is fractured. This map of the crack area, how does it show up, can be understood from the geometry. Look for this geometry and for the loading. So if you know that, if you see something like this, this is because there is stress concentration. If you have a V notch like this, you should expect that this topography, okay, or morphology of the surface become different depending on the surface itself. So you would know what is the story. You can tell the story based on the surface, based on the loading, based on the geometry, you will see different lines being marked in the specimen after its failure. Okay, those are too many examples showing you how to determine even if it is shear fracture or shear fatigue, or is there a mean stress, is there eccentric loading, all because you look under the microscope. Okay, this is just for you to know the whole thing. So what is important is that يا شباب السلايد اللي أنا عديتها, this is just a textual explanation of what I was talking to you about. So how do we analyze fatigue, يا شباب? There are several methods, okay? The first method is called لحظة يا أخوان, I think how much time now we have? I think we need to start the quiz, يا شباب. That's it. Let me stop this. Can you please, يا